Okay, ladies and gentlemen, so again we're going to take a look at finding the rule of a sinusoidal function. And let's remember that for sinusoidal functions we have the choice between using f of x is equal to a sine of b x minus h plus k, and using f of x is equal to a times the cosine of b x minus h plus k. Now we've already seen examples using the sine function. How about we try this example using the cosine function rule? So again, our first task is to find our first cycle of a cosine function, and it can start anywhere as long as it looks like a cosine function. So that means that you're either starting it at a maximum or at a minimum. So for example, we could choose this particular cycle, or we could choose this particular cycle. It really doesn't matter as long as it's looking like a cosine function, which means it's starting at a maximum or it's starting at a minimum. Usually though, people will choose something that is closest to the y-axis. So, and again, it doesn't really matter which one you choose, but for the purposes of this example, let's just follow that convention and choose a cycle that starts pretty well close to the y-axis. So here's going to be the first cycle that we're going to take a look at. Now, we need to figure out the starting point of our function, because that's going to be giving us the h and k value. Now, it kind of appears that the starting point of our function here is going to be at 1, 1, but this is not, I repeat, this is not our h, k, because for the cosine function, the maximum occurs above our starting point. So our starting point in the cosine function doesn't actually exist along our function. It is just some value that is below. It's at the center of our function vertically. So our hk value in this case is actually 1, negative 1. So when we write down our function rule, it's going to reflect this. And remember, we've chosen the cosine function. So the rule is going to look like f of x is equal to a, which we don't yet know, cosine of b, which we don't yet know, x minus 1 minus 1. And now, just like before, we need to figure out what our a parameter and our b parameter is. And let's remember that our a is equal to plus or minus the amplitude. The amplitude of this particular function is 2. So we're going to have an a value of plus or minus 2. Our b, let's recall, for sinusoidal functions is equal to plus or minus 2 pi over the period. And the period is the length of time or the length of distance, space, whatever it is that the horizontal axis represents. It is the length before the cycle begins to repeat itself. So here the cycle starts at 1, negative 1, and the cycle ends at 5. And so the distance between 1 and 5 is 4. So here for our b parameter, we're going to have that b is equal to plus or minus 2 pi over 4, which means that b is equal to plus or minus pi over 2. And again, we're going to have to choose whether we want our a parameter to be positive or negative, and whether we want our b parameter to be positive or negative. Now, because this looks like the first cycle of our cosine function, it's going to mean that our a parameter is going to be positive because it's starting at a maximum. And our b parameter doesn't really have an effect on cosine functions because cosine functions are symmetrical over the y-axis. So it doesn't matter whether you're going to choose the plus or the minus for the b parameter. Now, most people prefer to use the positive b, and so we'll just follow that convention again, and we'll rewrite our function using our parameters as f of x is equal to 2 cosine of pi over 2 x minus 1 minus 1. Now again, just like before, we just arbitrarily chose our random starting point, knowing that it was a cosine function, as being some value that was going to be starting at a peak. But for the cosine function, you can choose something that's going to start at the bottom, at the minimum in a valley. And that's not going to change well, it's going to change the representation of our function, but it's not going to change what it looks like graphically. So what I mean by this is that it's going to change our function, but instead of looking at the blue cycle that we have on the board, what if we took a look at this green cycle? Oops, sorry, wrong color. What if we took a look at this green cycle, which is going to be right here, and it's going to overlap with the blue cycle a little bit, and it's going to end here. Now this again looks like a cosine function because it's starting at a minimum, sorry. But if we use the green function right here as our cycle for the cosine function, our hk value is not going to be -1, 3. So this here is again not our h, k. This just represents the location of one of our minimums. Our h, k actually finds itself slightly above, right in the center of the function, right in the vertical center of the function. And we can start writing our cosine function down as, switch to black, we can write our cosine function now as f of x is equal to a cosine of b x minus -1, so it's x plus 1 minus 1. So we've changed the location of our h and k. We've changed the location of our starting point for the cosine function. Now, our values for the a parameter and for the b parameter don't change. They're still plus or minus 2, and they're still plus or minus pi over 2, respectively. But now we have to make a choice for our a parameter. Remember that for the cosine function, our b parameter doesn't affect it at all because it is one of these even functions. So when we take a look at our a parameter, we'll notice that this time, instead of starting at a maximum, we're actually starting at a minimum. And because we're starting at a minimum, we have no choice but to choose the negative a parameter. So when we're going to write down our function rule, we're going to write it down as f of x is equal to -2 cosine. And we can or we cannot choose the negative. It doesn't really matter here again. But by convention, most people will use the positive b parameter. So it'll be pi over 2 x plus 1 minus 1. Now, its algebraic representation looks different than it did before, but its graphical representation is the exact same thing. Okay, so you can choose to use either of those two function rules. It doesn't matter. They're both valid for the function that you see up on the board.